Hi, in this video we will talk about how to interpret a blood gas analysis. We will do a series of videos for interpretation of the blood gas analysis because we can't complete in one video. Basically, blood gas analysis is a very important test. It gives us a lot of information about a patient. It gives us information about the acid-base balance in a patient. It gives us information about the oxygenation status of the patient and also the ventilatory status of the patient. Here we will focus on the acid-base balance disorders. Basically, we have 5 acid-base balance disorders: metabolic acidosis, metabolic alkalosis, respiratory acidosis, respiratory alkalosis, and mixed acid-base disorders. Mixed acid-base disorders, we will talk about it in another video. Here we will focus mainly on those 4. The pathophysiology of these 4 conditions also we'll talk about it in another video. Here we are focusing only on the interpretation of BGA, how a blood gas analysis will tell us what type of acid-base disorder a patient has. So in short, to understand what is acidosis and alkalosis, you can assume our body is like a container where you have a balance of base and acid. Here acid is the hydrogen ions and the base is bicarbonate. So you see there's a balance. If it's balanced, it's neutral. There's no acid-base disorder. So in a state where you have excess of hydrogen ions or acid or a decreased bicarbonate, so there is inequality. There's more of hydrogen ions. So in this state, this is an acidic state. So this is an acidosis picture. While in another state where you have inequalities, where you have more of bicarbonate, more of base than acid. And this can occur if there's increase in base more than the normal, or there is loss of the acid more than normal. So here in general you have more base than acid. So this will be what you will see in an alkalosis picture. So if you want to interpret the BGA, basically in a BGA you will have very many parameters. 3 parameters are enough to be able to identify what type of acid-base disorder it is. And to be able to interpret that, you just need to ask 2 questions. Number 1, what is the primary problem? Is it acidosis or alkalosis? Once you have answered that question, you go to the second question. What type of acidosis or alkalosis is it? Is it metabolic or respiratory? Once you've answered those 2 questions, you have answered the problem. So let's see. We have 3 parameters. The first parameter is the pH. pH is the indicator to tell us whether it's acidosis or alkalosis. It's the one that will answer the first question. Then we have PCO2 and HCO3. These 2 will help us answer the second question. How? We will see. So we have to know the reference ranges of each. Normal reference range of pH is 7.35 to 7.45. There are no units. So if pH is lower than normal, that is acidosis. If pH is above normal, that's alkalosis. So if normal is between 7.35 to 7.45, if it's below 7.35, that's acidosis. If it's above 7.45, that happens in alkalosis. So in this case, the pH is 7.2. That's less than 7.35. It means this is acidosis. Now we have answered the first question. This patient has acidosis. Now the second question. What type of acidosis is it? Is it respiratory or metabolic? So this one can be answered by looking at these 2 parameters. We have a PCO2 and a bicarb. Basically, these two parameters are telling us the equality between the acid base. That is, bicarb is a base and PCO2 is an indicator of the acid, because we know carbon dioxide, when it dissolves in water, it forms carbonic acid. So PaCO2 is an indicator of acid and bicarb is an indicator of base. So if you just look at bicarb in isolation, if you just look at the PCO2 in isolation, first of all, what's the normal reference range? The reference range is between 35 to 45 millimeters of mercury. So if it's less than 35, what is it? See, PCO2 is an indicator of acid. If it's less than normal, it means it's going towards alkalosis. And if it is more than normal, it will cause acidosis. It's like you are increasing the acid, so it will cause acidosis. So if it's lower than normal, you are reducing the acid, so it will cause alkalosis. So now, if we are just looking at it in isolation, if we see that PCO2 has gone below normal, then there are two possibilities. Either it is the primary problem or it is the compensation. For example, let's say the PCO2S of in this state is 31.5. It's lower than 35. So it means it is going towards an alkalotic picture. So either this is the primary problem. If it's the primary problem, then it means the patient will be having an alkalosis. Or the other possibility is that the patient is having an acidosis, but the body is trying to compensate by reducing the hydrogen ions, by reducing the PCO2 to try to bring back the pH to normal. So either it's the primary problem or it's a compensation. Similarly, if the PCO2 is above normal, there are two possibilities. Either it's the primary problem, that is, it's causing an acidosis, or it's the compensation. It means the patient has an alkalosis and the body is trying to compensate by increasing PCO2. So how will we know whether it's raised or reduced because of the primary problem or because of compensation? You can know that by looking at the pH. If the pH is acidic, it's pointing towards acidosis. And the PCO2 is pointing towards acidosis, that is, if it is higher than normal, then that's the primary problem. If the pH is acidosis and the PCO2 is pointing towards alkalosis, that it is lower than the normal, it means it's compensation. Similarly, bicarbonate. Normal reference range is between 22 to 26 millimoles per liter. If bicarbonate is lower than 22, it means you are losing bicarb, you are increasing acid. So that occurs in acidosis. And if you are increasing bicarb to more than 26, you are going towards alkalosis. So if your bicarb is less than 22, it's causing acidosis. It's either that's the primary problem or it's a compensation for an alkalosis. And if it's going higher than 26, it's either causing a primary alkalosis or it's a compensation for an acidosis. So that's why we start with the pH. It tells us from before whether it's acidosis or alkalosis. And then from there, we can identify which one is a primary, which is compensation. And then the other thing is, PCO2 gives us information about respiratory and bicarb gives information about metabolic. So in short, let's try and answer the first question. pH is 7.2. It's less than 7.35. It means this patient is acidosis. Respiratory PCO2 is 31.5. It's less than 35. So it means PCO2 is going down. If it was a respiratory acidosis, we will have expected PCO2 to go high, to be the one that is causing the low pH, but it is in the opposite direction. It is going low, it is reducing. If you look at bicarb, we see with 14.7, it's less than 22. It's the one that's going down. So we see the bicarb is going down, and bicarb goes down in acidosis, and the primary problem is acidosis. So this is a metabolic acidosis, and the PCO2 is going down to compensate for the acidosis. So this primary problem in the first case is metabolic acidosis. Let's go to the second example. pH is 7.5. Normally is between 7.35 to 7.45. 7.5 is above 7.45. So this is an alkalosis. PCO2 is 49. It's between 35 to 45. So it's more than 45. It's 49. So it's more than 45. So if PCO2 is more than 45, there's more, it's increasing hydrogen ions. This occurs in acidosis if it's a primary problem, or it occurs as a compensation in alkalosis. And one of the primary problem here is an alkalosis. So if PCO2 is high, it means that's as a result of compensation. We come to bicarb, 38. Normal is between 22 to 26. If it's more than 26, it means it's alkalosis. So it means the primary problem here is metabolic alkalosis. And PCO2 is just rising to compensate for the metabolic alkalosis. Let's come to the third example. pH is 7.5, so similar to this. But so that is alkalosis, more than 7.5. Now look at PCO2. It's 28. It's lower than 35. So the acid is going down. If acid goes down, we have more alkali. So it's the one that's causing the alkalosis. What's problem in bicarb? Bicarb is normal. So it's PCO2 that's causing the alkalosis. So it's respiratory alkalosis. In this state, the bicarb can be normal, or it can also go lower to compensate, to bring back the pH to normal. In the last case, pH is 7.2. 7.2 acidic or alkalosis, acidosis less than 7.35. The second question, respiratory or metabolic. Now PCO2 is more than 45. So PCO2 is higher than normal, means more hydrogen ions. It means this is the one that's causing the acidosis. Bicarb is 24, between 22 to 26, so that's normal. So it means this patient has respiratory acidosis. Bicarb can be normal, or it can also increase to compensate. So that's how we can interpret a BGA to be able to know the primary acid-base disorder. Now one thing if you've noticed is the direction the PCO2 goes is the same direction the SCO3 goes to maintain the balance. See, both are different charges. One is an acid, one is a base. So if PCO2 goes down, bicarb has to go down to maintain the acid-base balance. And you see in both cases, in all these four examples, they'll be going down or up in the same direction. If in case the directions are different, that suggests something else, which we'll talk about in another video. Now finally, one more thing is we can be able to classify acidosis or alkalosis in terms of severity, whether it's mild, moderate, or severe. If it's in case the pH is between 7.3 to 7.35, it's mild acidosis. If it's between 7.2 and 7.29, it's moderate acidosis. And if it's less than 7.2, it's severe acidosis. In terms of alkalosis, if it's between 7.45 and 7.5, it's mild alkalosis. Between 7.45 and 7.55, it's moderate alkalosis, and more than 7.55 is severe alkalosis. So in this video, we have learned how to interpret a BGA to be able to identify the primary acid-base disorder. Next, we can talk about compensatory mechanisms, then mixed acid-base disorders, followed by the oxygenation status and the ventilator status of the patient. Thank you.